Every outage you've seen from an expired or misused certificate usually starts in the same place, with a bad template. In this module, you'll learn to design templates as architectural blueprints that enforce identity, security, and automation across your entire PKI. To implement PKI effectively on Windows, you need to understand how certificate templates evolved across server versions. Version 1 templates in Windows 2000 were fixed, stored in the CA database, and had essentially no access control. Version 2 in Windows Server 2003 moved templates into Active Directory and added full customization, security ACLs, and auto-enrollment. Versions 3 and 3.1 in 2008 and 2012 introduced CNG and modern algorithms. Version 4 from 2012 R2 onward is the current enterprise baseline with the broadest features and compatibility. When you pick algorithms and template features, you're really choosing a compatibility level between your CAs and your endpoints. At the low end, you keep broad legacy support, but you're stuck with older cryptography and can't use newer key usages. Once both CA and client operating systems are modern, you can enable CNG keys, stronger algorithms, and richer key usage without breaking devices. The decision is to consciously balance nice features against who will be locked out, and to document tested endpoint support before you publish any template. For identity mapping, treat users, devices, and services differently, but align all of them with your IAM model. User certificates should map cleanly to a single account, common name plus UPN and email in the SAN, driven directly from AD attributes. Device certificates should favor stable technical identifiers, FQDN or device name, with DNS or GUID-style SANs that match Intune or MDM records. Service certificates should prioritize routing, DNS names in subject and SAN that reflect all endpoints and load balancer VIPs. A certificate profile has 3 layers. First, the mechanism. Key usage. This is the raw math the key is allowed to perform: signing, key encipherment, or key agreement. If this is wrong, the certificate may technically work but be misused. Second, the authorization, extended key usage. EKUs define which scenarios are allowed, like client auth, server auth, or smart card logon. Keep EKUs as narrow as possible. Third, the engine, cryptographic settings. Here you choose RSA versus ECDSA key size and provider, balancing security, performance, and platform support. When you design templates, always distinguish standard keys from high-value keys. Standard keys cover everyday encryption, user email, file encryption, and typical application, TLS. These keys can be exportable or archived, but only under tight data recovery policy. High-value keys are different: domain controllers, code signing, and CA roles. Keys here must be non-exportable, bound to hardware like TPMs, HSMs, or smart cards, and explicitly forbidden from archival. Combining these models in a single template is a serious design mistake. Template permissions work like concentric security rings. Read is the outer ring. Many identities can see the template so they know it exists. Enroll is narrower. Only specific security groups, devices, or service accounts should be able to request that certificate. Auto-enroll is tighter still. These identities get certificates automatically through GPO or MDM, so any mistake scales quickly. At the core is manage or full control, reserved for a very small PKI admin group, not general domain admins. You can also think of your templates as 2 security zones. In the standard zone, you enable everyday user, device, and server authentication. RBAC still applies, but the blast radius of a mistake is limited. Privileged templates are different. Code signing, domain controllers, and smart card logon can fundamentally change trust. They require very narrow EKUs, tightly scoped AD groups, strict change control, and separate monitoring. The objective is clear. Compromise of a standard certificate is annoying. Compromise of a privileged certificate must be unlikely and quickly detected. Template migration is about controlled overlap, not big bang change. You introduce version B with stronger crypto, while version A is still trusted. First, publish the new template, but don't change clients yet. Next, update auto-enrollment so new or renewing certificates start using version B. During this overlap, clients naturally pick up the superseding template and you monitor for issues. Only after most active certificates have rolled over do you retire version A, avoiding mass expiry and outages. Treat certificate templates as products with a managed lifecycle. While a template is active, track where it's used and who depends on it. When you decide to deprecate it, start with Do Not Use. Remove enroll and auto-enroll so nothing new is issued, but you can still see existing certificates. Once you're confident nothing relies on it, unpublish it from the CA. Finally, continue auditing issued certificates to find any survivors and migrate those workloads to approved templates. Introducing or changing a certificate template should feel like a mini security project, not a checkbox. Begin by capturing the business justification and doing a risk and crypto impact assessment. Who needs this? What keys and algorithms are involved, and what could go wrong? Then route it through PKI governance and your change advisory process, so multiple stakeholders sign off. Only after approvals do you implement, publish, and version it. Updating configuration history and compatibility notes so future engineers understand exactly what changed and why. Each certificate template acts as a hub with two major spokes. One spoke serves devices using NDES and SCP. Here, the template defines exactly which EKUs, key sizes, and compatibility options network gear and MDM clients can use. If these settings are wrong, routers or Intune enrollments simply fail. The other spoke serves Windows endpoints via auto-enrollment. Those same template settings drive group policy behavior, including renewal timing and whether duplicates are allowed, so precision here directly determines fleet stability. Overall, think of your certificate templates as a product line, not ad hoc tickets. First, standardize patterns. Keep a small, well-defined set of templates per use case. That's what makes automation, support, and audits manageable. Second, enforce least privilege. Keep EKUs minimal, scope enrollment groups tightly, and use non-exportable, hardware-backed keys for anything high value. One overprivileged template can undermine the entire PKI. Finally, treat lifecycle governance seriously. Any template change should go through risk review CAB and documentation, just like changing a critical production service.